Hey everyone, Terry here with IP Expert, and what we're going to be doing now in this portion of our CCNA video on demand series is we're going to start taking a look at what's involved with regard to how we secure our environments. And we're going to divide this security into three primary categories. First, we're going to take a look at what's going on when we want to do security with regard to administrative access. Then we're going to look at a concept called device hardening, and then ultimately we're going to look at how we can use access lists. Yes, we're going to begin revisiting access lists again, where we're going to be focusing on how we can deploy access lists in order to be able to provide significant amounts of security in the confines of being able to work with our devices and our infrastructure components. So when it comes to working with how we can configure restriction to security access, honestly, we have to understand the simple fact that network device security comes to us in multiple forms. In fact, we need to protect ourselves from many threats. Some of them would be threats that we wouldn't ordinarily consider, but they can cause significant issues. For instance, one of the threats is the fact that we can find ourselves faced with electrical threats. For instance, voltage spikes, over voltage scenarios. We can find ourselves in areas where we have maintenance style threats, where we got improper handling, we've got poor cabling, we've got bad design, as well as inadequate labeling. So the idea here is just because I have equipment in my rack, 5 months from now, I may not understand or remember exactly what each of those individual devices do. Also, we have to take into account that this risk involves rollover. So as I have individuals who are familiar with my infrastructure and they attrition out and they're no longer part of the support team inside the confines of the company, we acquire new individuals that know less and less about the network. And that's going to be problems. But again, we also need to recognize that we have to protect ourselves from remote threats. The idea of individuals outside of our infrastructure trying to be able to come in. But also, just as important, and possibly even more important, we have to learn how the fact that we need to protect our network from assets and resources and individuals that are actually on the inside. Now that means we need to start looking at things with regard to who has the ability to access what devices, when they have the ability to access it, and what role-based privileges those individuals are going to have when they do access our devices. Also, we need to understand the fact that we have local access and physical threats. Keeping in mind, sometimes the best security isn't going to be a router or a switch configuration, it's going to be a locked door or a cipher key or some pass access mechanism whereby we have the capability of controlling who has what access to particular devices in our infrastructure. Now, we've already done some of these things. These are very basic things. I can set up passwords. For instance, when I type enable, if I don't have the password, I can set it up to where my device is going to refuse access. That being enabled through this concept of the enable password. Remember, I can enter that in global configuration, and it also is going to allow me to use case sensitivity. Therefore, I get the capability of being able to have more support and better security inside my infrastructure. Another component here is that when I have enable password, that's really the old way that we do things. It's going to store my password on my system, and I'm going to be using that in order to be able to access the system. However, we do have in more modern versions of iOS this concept of our secret password. So rather than saying enable password, I'm going to specify enable secret. Now, the ultimate thing here is when I look at these, I can actually go in and say show running configuration, and I can include parameters for my configuration with regard to how it exposes to enable. So in other words, all I'm doing here is I'm using the more symbol and saying including anything inside of the running configuration that involves enable. And the two options that I'm going to see is, first of all, my enable password, which notice is saved in clear text. Also, we're going to see the enable secret, and what we're going to find is we're going to have a hashing algorithm that's going to give me some modicum of over-the-shoulder security with regard to somebody being able to look over my shoulder and be able to see exactly what my configured password is. Now, our security requirements don't end there because we also have other things that we want to take into account. And that's going to be, again, this idea of whether or not we're going to be encrypting our passwords. So I can have and engage a service password dash encryption, which means anything that I enter into the router is going to be encrypted when it's involving some type of password. Now what we need to see here is then once I've enabled the service, it's going to go so far as to actually encrypt the enable password configuration. Again, this is just over the shoulder security. Prevents somebody from being able to look at what I have on my console and determining what my actual password is. I would not call this high levels of security. It just gives me the capability of setting it up to where no one can capture my password easily. Also, we have to understand that we have to protect the avenues of approach that we have to our infrastructure. When it comes to security, there's a variation called NFP, Network Foundation Protection. Network Foundation Protection means we need to recognize that we have to protect our control plane, our forwarding plane, and our management plane. The management plane is going to take into account every interface or every method that I have to be able to connect to a device in order to manage it. That's going to include my VTY lines, it's going to include my console, and other components like that. And this is what's being illustrated in these commands that we see in the presentation. Notice what I have here is I have my console config. So access console 0, I can specify a password, and then I can utilize the login option. We've already done this in one of our labs. Walk through it. Also the exec timeout. Now you'll notice in my labs, I turn exec timeout off. I say no exec dash timeout. I can even go in here and say exec dash timeout 0 space 0. Now that means I'm not going to use executive timeout. In a real world environment, that's not something that we want to be able to do. It's not something that we would ordinarily entertain. The rationale is that if I'm working on my console and I get up and walk away, what's going to happen is that if I don't have these values set, the system is not going to boot that connection out. So while I'm gone, while I'm in the restroom, someone could come and access my laptop inside the infrastructure and they'd have direct access to all of the stuff that I was working with on my controlling device. So again, it's going to be something that we want to actually employ, but in the lab it can become pretty problematic for us getting booted out because we're reading something or we're studying. And like I said, that's where we go in and we manipulate this idea of changing our remote timeout variables. Now also, we need to recognize the fact that the system is also going to allow us different methods of connectivity. One of the methods that we've already employed was Telnet. Telnet is unsecure by its very nature. So if I want to use a solution that's not going to send information in clear text, what I want to be able to do is I want to employ another scenario which is called SSH, Secure Shell. Now Secure Shell allows me to create a situation where I define a key, an RSA key. And that RSA key needs to be known on both the host, the device that I'm trying to control, and the management device. And what ends up happening is that I can create that, first of all, by assigning a host name and then configuring a domain ID. And the moment that I have those two pieces of information, I can actually create this process whereby I create a RSA key. Now notice here we have modulus. The modulus is going to be a factor of how complicated the key is going to be. So if I have a 128-bit modulus, that means I'm going to have a much more secure or a much difficult password or key to be able to actually hack or overcome or copy than I would if I was using a lower version or a lower level of modulus for the calculation. So again, keeping in mind also I needed to convince my router and my device that it's going to support SSH, and that's going to be to employ the transport input command. Transport input is going to be on by default for Telnet. If I want to be able to modify it such that I'm only going to use Secure Shell, then I want to do the specification there, import SSH. The other thing is that at the global configuration level, I need to recognize what version of Secure Shell I'm going to use. We'll see 1, we'll see 1.99, and we'll see version 2. All that 1.99 means in some of the older versions of iOS is that it can support both version 1 and version 2. So it was kind of like an interim solution in order to be able to adapt and have iOS work with the different solutions. But again, what we need to recognize here is that we also have commands that we can use to verify that we have connection to secure shells. So I can go in and I can say show IP SSH, and it's going to tell me all of the information associated with my version, what one's enabled. It's going to give me any of my authentication timeouts, so the time it's going to take me to authenticate to the system, and it's also going to tell me how many times I can try to do this. One of the primary things that we want to take into account with security is that one of the best ways to protect ourselves is to restrict the number of times that an individual that's trying to attack our system can try to log in. So 3 retries, then it boots us out and they have to start over again. This protects us from situations where people are trying to do something like a brute force attack in order to be able to get in. And we can also show SSH, which is going to give us the information associated with our particular active connections using Secure Shell. Now, Secure Shell, like I said, is not the only solution that we have, but it is the better option as compared to using something like Telnet. Like I mentioned previously, Telnet is not secure. But we also have to understand is more often than not, we need some kind of client, and also we have to take into account this idea of the RSA key. So what's going to happen here is I can use solutions like PuTTY, which are free, and it's going to be the solution that you're going to use, like if you go all the way up to the CCIE lab, that's going to be the solution that you're going to be using. So it's really, really good to become familiar with it, even at the CCNA level of study. But even there, when we do a secure shell, what we're going to have to do is we're going to have to accept the key. The moment we have the key accepted, then we're going to be able to connect to the system and leverage Secure Shell for the purposes of performing management. Now also, we need to recognize here that we also want to have different solutions, and default gateways are extremely important for us. Default gateways control, i.e. where our traffic's going to go if we don't have a more specific route. One of the command options that we have is going to be able to go into the device and say IP default gateway, and we can specify the address that's going to be used on that particular device. And it's going to normally allow us to be able to do it in the context of a switch. And that's going to give us the connectivity information such that we can reach the default gateway, which in most scenarios are going to end up being our routers. Now, when we continue this logic, we also need to understand that what we want to do is we want to necessarily restrict access. And we have a perfect tool that we can use to restrict access. In fact, you saw me in my demo, I was using it in order to be able to try to prevent the ability to do a telnet session. So when we go in and we start looking at this, we can use access lists. ACLs allow us to control who has what capability to access the infrastructure. Now, when I set up the access list on an interface, I used IP access -group on the interface. Now, if I want to protect myself from someone being able to connect via telnet via a TTY session or a VTY session, so they're telnetting to an IP address, what I can do is I can go under the VTY session and I can actually apply the access list inbound using the access list that I configure, saying it's going to permit these people to log in, it's going to block everyone else. And what we see here is we see the log option. The log option means that every time something happens with regard to being able to match this bottom criteria, my deny all, what's going to happen is it's going to pop up a console message. So it's going to log it on the screen or during the session on the router itself, or the switch for that matter. But keep in mind, we use the access-class command on the VTY connections, and again, we have to specify the direction. Now here's another interesting tidbit. If I did this on the basis of applying an access list out of the TTY session, that means that I would be able to connect, but what I could do from there is I could say I can use this access list to filter other devices or to prevent me from being able to jump from this router to another via executing telnet on the router or the switch itself. So again, it gives me a significant amount of granularity with regard to controlling who has access to what, and even after I get access, I can use it in order to be able to restrict communication. Another solution, one that's going to be far, far more useful to us, is going to be the concept of AAA. Authentication, authentication, and accounting, AAA. Those are going to be through the use of specially designed servers like TACACS and Radius servers that we can use to be able to have huge databases of not just who has the capability to access the system, but we can also control privilege, the ability to access certain particular commands based on the variables that are contained inside the Radius or the TACACS server. Typically Radius in that scenario. But again, what's going to end up happening is we're going to have a third-party authentication server that's either going to be an industry standard solution like Radius or TACACS, which is going to be a Cisco proprietary solution, most notably TACACS Plus. I mean, there was a TACACS, but it obviously has evolved. And it's going to give us the capability of offloading the administrative burden of authentication, authorization, and accounting to a server so that we can relieve the strain off of our routers and our switches so that now we end up getting the capability of being able to implement things. Also, one of the probably less known or less considered security solutions is a concept of banners. Because if you access a device and you're an honest person, what ends up happening is unless there's something telling you that you're not supposed to be there, you're not going to necessarily be concerned with having to exit or get off the device. A banner, a message of the day banner, gives me the capability of citing specifically the fact that people are not supposed to get here unless they have specific access. And it's all going to be based on the user connecting to the actual device. So we will implement the banner login configuration here. So the moment that this pops up, what's going to happen is the moment I authenticate, this is going to appear on the screen. It gives the user a warning to let them know that they're not necessarily supposed to be able to access this device. Now, again, this is just an interim, an introduction, or a cursory look at security. We've seen the options, we've seen the components, and what we've seen is how we can use access lists to control who has access to what, or once they get access to a device, where they can go from there. Now, our conversations need to continue, especially in the confines of what's going to be termed device hardening. So I'll see you guys in that lecture very soon.